Okay, today's topic of discussion is the law of cosines. So we're going to use the law of cosines now to help us solve triangles, just as we did the law of sines, and they will definitely be helpful for non-right triangles. So knowing that, let's move forward and say, let's look up the combination we want to be able to solve and find missing parts of triangles, and if they're not going to be right triangles. And if you think back in our law sines section, we did angle, angle, side, side, angle, side, and side, side, angle. So now our goal is to look at and only use side, angle, side, or side, side, side. So think about, I have more edges than I do angles included. So it's probably actually easier to remember side, 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 and side, angle, side go with cosine. All the others go with law of sines. So looking at our triangle ABC, you will notice a couple things. There's three ways to write it, but there's only one way that you have to remember. So I'm just going to pick the top one as our guide here. And it doesn't matter which one you look at, they all have those characteristics. But basically, taking a look at your triangle that's drawn, if we look at little c, which is a side opposite of c, so if we look at little c, it has to be on the extreme part of the equation from its angle. So little c leads off, it's an edge length. Angle C is at the far end. And notice it's the only angle in the entire formula. So after that, it sort of looks like Pythagorean theorem a little, a squared plus b squared, and then minus 2ab. So you're using those same edges. So you definitely have all the edges, or you have a side angle side relationship. So right now, if the angle is missing, C would be the unknown. If angle C would be the unknown. If the edge little c was missing, little c would be the unknown. We're going to do an example shortly with some numbers. And then I would use little a and little b as the two pieces that belong in it. But the key is the edge and the angle that are opposite each other go on the extremes of this. The other two edges are the ones used in between. So you look at the next one, it's b squared, so angle B has to be at the opposite end. It's a squared, so angle A has to be at the opposite end. And then the unused edges are remaining in the middle part. So if we go with the idea that we need the law of cosines, and we're looking for a side, 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 remember, or a side, angle, side relationship. That's what we want in order to use either one or any setup of law of cosines. So looking at this scenario, points T and S are endpoints of a tunnel that'll be built, so it's not built right now, through a mountain from a point Q away from the mountain. It is possible for a surveyor to see both point T and point S. So he finds the distance of QS to be 720. QT he finds to be 510. Now again, with those surveying tools, compass-like, they can do some measurements. And then the angle that he's looking at from SQT is an 84.5 degree angle. So we can mark that as we did. And we then can say we have a side angle side relationship. So we'd be looking at that. So knowing that, the question is, as you see stated, find the length of the tunnel to the nearest meter. Well, the length of the tunnel is basically TS. And it's across from angle Q, so I'm going to call it little q. And that's going to be the variable we'll use in our writing. So here we go. We need that edge. And remember, the edge was opposite the angle in the law of cosines. So give us a little room here to write, and we'll go. So we know that little q squared has to equal our two other edges squared, so 720 squared plus the 510 squared, minus 2 times 720 times 510 times the cosine of 84.5 degrees. Now, if you look at that carefully, the whole entire right-hand side is numbers, number combinations. So you should be able to go right to your calculator, because those numbers are a little big to do otherwise, and punch this in. So go ahead and do that as I do it also. So we've got 720 squared, plus we've got 510 squared, minus 2 times and do not forget when you're going to put your 84.5 in that it is in degrees, and double check that your calculator is also in degree mode. And so 720 squared plus 510 squared minus 2 times 720 minus 510 times the cosine of 84.5 equals a number in the hundreds of thousands. But remember, that number is q squared. Okay, and double checking, I got a 708,110.87-ish. Okay, but we want to take the square root of that, so square root. And now the q value is coming out to be an 84.149-ish number. So we can look at that and say, based on the other measurements that in our problem, it's definitely the shortest edge, and are probably, which is true, shortest edge in the picture, but it's really not shortest because look at the angles. 84.5 is definitely not the size that's there. So the picture is not drawn to scale, as we like to say, and 841.48 would be the edge or length of this segment, which represents how long the tunnel in the mountain would be when we're finished. And that's what we were asked to find. Find the length of the tunnel to the nearest meter. So to the nearest meter, 841 meters. Done. Okay? So there's one example of law cosines. Here's the second one. In that, we start looking at it. It says, find the measures of the smallest angle in the triangle whose sides are 8, 10, and 12. So you have a triangle sitting in front of you. It's your job to label. It's unmarked, and maybe some of you didn't even give a triangle, but here we go. The smallest edge has to be the 8. The next one has to be the 10, and then we've got the 12. So now right now, you don't know what size angles you have. You just know that the three angles add up to 180. So if you look at this, we have a side-side-side relationship. And with a side-side-side relationship, you should go right to what are we looking for? It says find the measure of the smallest angle. Well, it has to be opposite the smallest edge. So right now that means we're looking for that angle. And if we didn't name it, what do you want to name it? ABC? That definitely is then angle C. So now that helps in your setup. Angle C is at one end of law cosines, and the edge is at the other. So let's set it up with our numbers in. 8 squared leads our equation off. Has to equal the other two sides squared, added together, minus 2 times each of those other two sides singly, times the cosine of C, which we do not know. Now take a good look at it this time. It's not like the last time where you can just punch it in. Your variable's at the other end. So you need to undo this equation step by step. And so here, talking through it, let's undo this addition. Get rid of the add 10 squared and 12 squared. We're not going to do any of the math yet. We'll save that for last. But if I bring that 10 squared over, it'll be subtract. If I bring the 12 squared over, it'll be subtract. Those would be gone. We'd have a multiplication problem left. So to undo multiplication, we divide on both sides by negative 2 times 10 times 12. Some of you might want to turn that into a number. That's okay. So we're looking at basically that arithmetic. So that would give us the cosine of C, and then we'd have to do the inverse cosine to find C. So if you'd like to go ahead and multiply your work on the left. So 8 squared plus, whoops, I'm going to back that up, make it minus 10 squared minus 12 squared. And close the parenthesis. You want to do the top first, and then divide that by new parenthesis, -2 times 10 times 12, close the parenthesis. I'm getting a 0.75. So then, if that's what the cosine is, you have to do, as we said, inverse cosine to get them gone, and you do that on both sides. And that should give us our C value, and inverse cosine does give us, if we round to the nearest whole number, approximately a 41-degree angle. And that's what they were asking for. Could we find the other angle measures? Yeah, but all they asked for was the smallest. So at this point, done, good to go, finished. So you can use the law of cosines to find edge lengths or angle measures, but knowing that you have to start with side-side-side relationship or side-angle-side. And if you memorize those two for the law of cosines, then all the other trig functions, triangle congruencies you learned go with law of sines. All right, so you now have two possibilities, and we've used all your triangle congruencies, so we should be done with those. We just have some relationships with sine, cosine remaining, but we'll discuss those another day. So bring any questions you might have back to class.